Hello, my name is Rolando Ferrini. I work for CSM in Switzerland, where I'm responsible of the activities in micro nano-optics. First of all, I would like to thank the organizers of the event for having given me the possibility of telling you in the next 10 minutes about the manufacturing of freeform micro-optics, which is the final frontier of micro-optics. First of all, just let me introduce my company that some of you may not know. So CSM is a Swiss private company, non-for-profit, that deals with technology transfer. So we develop technologies and technology platforms that then we transfer to industry. The activities I'm responsible for are in the field of micro nano-optics. How do we do micro nano-optics at CSM? We do it by UV imprints. We start always from designing and simulating the structures that we want to fabricate. How we fabricate the structures, we produce what we call an original that contains the original structures that we want to fabricate. It can be, for example, in glass, it can be in quartz. Out of this, we produce a nickel shim, which is the tool that we'll be using for production. And how we produce the structures, we put a UV imprintable lacquer on a substrate. And then we come with the tool, we press, and we shine UV light. When the light is absorbed, the photopolymer is cured and is hardened. Then we demold and the structure is transferred on the substrate. We can do this for prototyping on 6-inch wafers, but we are also trying to push forward our capabilities and bridging the gap which is between prototyping and volume production in two ways. On the one hand, going for larger surfaces. So we are installing these days new machines from a company called Photonics, which is a roll-to-plate machine that will allow us to go broader than 6 inches. And also we are pushing forward in the Death Valley between prototyping and production, which is the piloting phase. When it comes to volume production, we transfer the production to our partners, our industrial partners for production. And we are nowadays pushing this from after several years of experience in nano and micro-optics, we are pushing in the field of freeform micro-optics, where we are leading a European project that is meant to set up a pilot line for the manufacturing of freeform micro-optics, PHABULOuS. So first of all, before telling you about PHABULOuS, how PHABULOuS is linked to automotive lighting, I would like to tell you about freeform micro-optics. For sure, you know freeform optics, which is today a product reality in automotive lighting. These are optical components where you remove any symmetry constraints on the surfaces. What you can do, you can add new functionalities, you can simplify your optical systems, you can easily integrate these new optical systems, for example, in lighting systems containing LEDs. You also know micro-optics. These are, in general, for example, microlens arrays that allows you to miniaturize your optical system, to add new functionalities, go for low weight and large area optical elements, which can be flexible or conformable, and low cost at mass production. Now you put together the two domains and you have freeform micro-optics. So micro-optical elements where you lose symmetry restrictions, as you can see here on this slide on the bottom right. This is not technology push. There is a real market interest. As you can see here from on left bottom, you have a graph showing how quick the patents and the publications in the field of freeform micro-optics were growing in the last 2-3 years. So there is really a request, a demand from market, from companies to integrate freeform micro-optical components into their products. One of the hottest markets that we have identified is automotive lighting. In automotive lighting today, micro-optics is already a reality. It's a product reality. You see here, for example, double-sided microlens arrays produced by a company in Switzerland, which is also part of the PHABULOuS micro-optics. These elements put in front of LEDs integrated into, for example, the side mirrors, produce this marvelous light carpet that you can see here around the car, which is more an aesthetic factor. But this is actually booming as field. And today, more and more companies are looking into freeform micro-optical components also to be integrated into, for example, other more functional elements in the car, like headlamps. This is, for example, the objective of Hella, that you for sure knows, that is one of the use case partners in PHABULOuS. I will tell you in a few minutes what a use case partner is. But the objective of HELLA is to look into freeform microoptics for automotive, especially automotive headlamps, with the idea to manufacture or enabling the manufacturing of these innovative components that are meant to reduce, for example, or simplify the optical systems that are integrated into the headlamps and to improve the efficiency of the optical systems. Here you see the advantages that have been identified by HELLA for freeform microoptics applied to headlamps. In general, it goes a lot with the simplification of the optical systems, combining different optical functionalities in one single element. You can also combine several optical surfaces in one single surface. And at the end, your complex optical system is simplified, is easier to be integrated, which reduces the cost of production, but also allows to produce or to have new, more efficient lighting products. The idea of HELLA in PHABULOuS is to explore freeform microoptics or the manufacturability of freeform microoptics for two functions in headlamps, low and high beam. The idea is to have headlights with uniform appearance in on-off state, with high beam and asymmetric low beam with low stray light, homogeneous light distribution, which is very compact a system and low weight. That's the objective. And actually, before getting there, you have to manufacture these optical components. And it's where the problems, let's say, in general starts, because fabricating freeform microoptical components is not easy. It requires the access to very advanced technologies, and the value chain to produce these components is broader than a standard value chain for microoptics. So what's PHABULOuS and how PHABULOuS can help and to put on the market new products with new freeform microoptical components? PHABULOuS is one-stop shop for the manufacturing of freeform microoptics, offering accelerating innovation and production cycles, manufacturing services going from prototyping to piloting to large volume production. PHABULOuS was born at the beginning of 2020 as a European project that got 15 million funding from Brussels in order to set up this distributed pilot line. What is a distributed pilot line? Distributed pilot line is a pilot line where each element on the value chain exists in a specific place, but not on the same spot. So there will be several partners you can see here distributed in Europe. Each of them masters one element on the value chain. And putting together these partners, we'll have a distributed pilot line. There are another set of partners that you see here, which we call them the use cases. These are not part of the pilot line, but they're helping the technology providers to set up the pilot line. How? Just testing their production processes against product needs in order to be sure that this is not technology push, but it's market pull, so that what we are setting up as production line can be immediately functional to the selected markets, among which there is, for example, automotive lighting, where we have HELLA as partner. But we have also general lighting with Suntobo, transportation lighting with Zeissenbacher, with luxury with Swarovski, and AR/VR with Microlight and Limba. So what we are building is this value chain that you can see on this slide. So we'll cover the entire value chain for the production of freeform microoptical components, going from modeling to the origination, which is one of the bottlenecks, where we have access to a lot of different technologies in order to be able to originate these small microoptical elements with no symmetry constraint. Tooling, because most of the time you can originate these elements on very tiny surfaces, so then you have to extend the structured surface in order to have your tool addressing the size that is required by your product. This we do with additional processes like, for example, separating. You need to tweak your materials for certain applications, for example, high-low refractive index materials. You need to control the quality of your imprint process. And then you have to go into production. And we go into production with three pillars. We go at wafer scale on wafers, up to 8 inches wafers with SUS microoptics. We go to roll to plate with more photonics. So the structure is on a roll that is depositing the structure in the surface of a plate. Here we can go up to A3, for example, even broader, up to 1 square meter. And when you want to go to really square kilometers, you go to roll, where we have a partner in Finland called Nanocomp. And then we integrate these elements into the products. How we are building the pilot line? We are building the pilot line in two different phases. The first 2 years are devoted to the pilot line setup. So we are really linking all the elements of the value chain in order to be sure that we'll have a smooth process workflow from modeling up to production and testing. And this we're doing, as said, with the help of the use cases that tell us what is compatible or not with their production or product requirements. In the second phase of the project, year 3 and 4, so starting from the end of this year, beginning of next year, we will open calls for what we call pilot cases. Pilot cases are companies that today are already willing to have prototyping or piloting of freeform micro-optical components for their products. They will apply for prototyping or piloting runs on the pilot line. If they are chosen, the advantage is that part of their work will be funded by the pilot line itself. And why where is the win-win situation is that we will actually work in close collaboration with these pilot cases, and we'll ask them to give us feedbacks on our production processes, but even more on our business model, because the pilot line is meant to survive after the 4th year of the project and remain as a self-sustainable pilot line serving the European industry requiring freeform micro-optical components. Why we're doing this? Why this effort from Brussels to fund the build-up of this pilot line? The reason is simple. If today you're a company, especially small and medium companies that would like to implement freeform micro-optical components in your products, you have to build your own value chain. You have to go through each of these steps and find the right partner and actually find partners or technologies that can match each other. This can be very cumbersome and time-consuming. This has two side effects. On one hand, prevents certain companies from having access to this technology. On the other hand, prevents the technology providers from increasing their business. So the solution we propose is to have one entry point with an optimized value chain behind that has been already optimized for the real production of freeform micro-optical components. And for which market we do this, you see here the list of markets that we have identified as the hottest markets requiring freeform micro-optical components, and it covers almost every market in photonics. The hottest markets are automotive lighting, solid-state lighting, AR, VR, and consumer electronics. And with this, I would like to thank you for your attention, to remind you that micro-optics is fabulous, and to leave you my contact details if you are interested in knowing more about PHABULOuS and freeform micro-optics. Thank you very much, and I will get your questions.